All right, let's get going. Earlier I mentioned that the Alliance has a task force on manure and biosolids. So our next talk is very relevant to that activity. And so we're going to be hearing from Ned Beecher, who is from Northeast Biosolids and Residuals Association, talking about the regulatory challenges associated with that sector of our system. So I suspect that the landscape he's going to describe is extremely rugged and precipitous and highly variable. And I think that's one thing that our project on biosolids is meant to identify. And hopefully we can smooth that environment over time. So take it away, Ned.
Okay. Hopefully, are you hearing this? Is it working? Okay. Got that? Okay. Thank you, and I appreciate the opportunity to be here. Thanks to Jim and to Matt and everyone for organizing this. It's great. I'm going to be talking fairly quickly through this. Fortunately, I know that the slides are available, so you can go back and refer. And the slides even have some supplementary material because I'm really bad at culling things down. So there's some supplementary slides available that you won't see today, but they're on the back end of this slideshow online. So we'll talk about why biosolids are recycled. Probably old hat to many of you, but just always like to review that. Biosolids regulations at the state and federal levels, and then phosphorus-related regulations that are impacting biosolids and other recycling residuals. The dynamics, so again, some of the review of the science of what the phosphorus dynamics are like in relation, especially to residuals. And then some ideas on improving state regulations. And as I said, supplementary materials are there. So why do we recycle biosolids? Well, first of all, organic residuals, organic wastes, so-called, are ubiquitous. They cause many issues in landfills, especially methane generation, greenhouse gas emissions. So there is a general drive to try to get these out of landfills and put them to use because, again, of the nutrients and organic matter available is good for soils and crops, etc. So, there's a whole bunch of different materials. We'll be focusing to a large extent on the biosolids and manures. Just a quick slide demonstrating some of the well-researched benefits of putting organic matter in soil: compost, biosolids, other residuals, putting the carbon into the soil, the nutrients back into the soil. Provides these many things. This is University of Washington data compiled not long back, but the research goes back decades, showing increased carbon as you put these materials into the soil. Makes sense. And that's a lasting increase of carbon that happens even when you stop applications. That carbon will be retained for a while. Microbial activity is increased in the soil. The water holding capacity of the soil is improved as well. That obviously makes a big difference in arid regions like this. And then the bulk density, which refers to the manageability of the soil, the tilth of the soil, etc., is reduced. All good things, all real benefits of organic matter in soils. Then looking, more at the greenhouse gas emissions. This is work we did a while back for the Canadian government, trying to estimate and model the emissions from different uses or disposal of biosolids materials. This calculator was developed from literature data and basically shows that when you landfill, the greenhouse gas emissions are significant. When you incinerate, it can be significant as well, depending on how you manage that. But the best option really, in many cases, tends to be anaerobic digestion, where you get some renewable green energy from that methane generated. And then you use the residuals on soils to replace fertilizer and sequester some carbon in the soil. So again, another benefit of recycling. In the US, this is old data now, but in the US about probably 60% of the wastewater solids that are produced at wastewater treatment plants are recycled to soil in some form. And in terms of where it's done, the darker the green is the higher level or percentages of recycled biosolids, wastewater solids recycled to soils in the US. Nutrient content of manures and biosolids are somewhat on the same level. So this is just to show that biosolids are used in agriculture in part because they have similar benefits in terms of the macronutrients. They have lower levels of potassium because potassium is more soluble and goes out with the effluent. And it's important to recognize that biosolids, even though in our world, biosolids get a lot of attention and a lot of concern because of whatever the traces of metals and chemicals and things that are in them, and those are all legitimate issues, and there's discussion of them, and we have answers and some uncertainties, et cetera, but manures are a much, much bigger source of organic matter that's recycled to soil, and a much bigger issue on the broad picture. So again, these are the types of different residuals that we're talking about. I left off, I forgot about paper mill residuals, for example, which in the northern tier has been in the past and a little less so now, but is a major source of organic matter that's returned to soils as well. So paper mill residuals should be on here. And there's other kinds of food waste, other gelatins even from film manufacturing and things like that are recycled to soil. But major ones are the biosolids, the manures, and compost. Digestates now is becoming a group of materials that come from the anaerobic digestion process. Some biosolids are digestates and they cross over. Some manures are digested too, so they produce a digestate. All these materials, though, are organic in nature, containing carbon, and they can be recycled and used as soil amendments. Interesting work being done some on incinerator ash there's no organic matter essentially left in that, but there is phosphorus and other micronutrients. So Germany uses some of that incinerator ash, and we're experimenting with that some in the Northeast and Eastern Canada. And then there's some residuals that are being used to try to reduce the availability. And I won't talk much more about that today, but the hydrosolids or water treatment residuals high in alum or iron are being used in places to try to retain or tie up the phosphorus in soil. And other materials have been used similarly, like gypsum. So we'll look mostly at these kinds of things. So the regulations. These are the big regulations that affect our world, the biosolids management world, and that's the federal Part 503 regulations, standards for use and disposal of sewage sludge, passed in 1993, and they are essentially a self-implementing rule that addresses things like metals, pathogens, and vector attraction, and chemicals to some degree in biosolids to make sure biosolids, when applied, are protective of human health and the environment. And the regulations provide general requirements and these kinds of things. They're the basic level of regulation for the whole US, and many states have adopted more stringent standards. But phosphorus is only addressed tangentially through required agronomic rate applications of biosolids. So, and for one type of or class of biosolids in particular, not for like a composted material necessarily. So usually in the past, as with manures, the application rates are based on nitrogen, but now more and more, some states are applying phosphorus as the limiting factor in application rate calculations. Food Safety Modernization Act is just coming into effect. The regulations from that are becoming effective in the last couple of years, and they basically indicate that biosolids, manures need to be applied or biosolids need to be applied in accordance with those 503 regulations at the federal level. So they haven't added many stipulations additional for biosolids. They've actually added more requirements for manure management, which are more consistent with the biosolids regulations now. So manures are now under FSMA need to be treated in some situations to ensure avoidance of pathogen issues. The other area of sort of federal regulation is not really regulation, but the guidance, of course, the Code 590 nutrient management or guidance documents. In 2012 was the last update, and in 2011 was when they first really explicitly talked about biosolids and other residuals beyond just manures and fertilizers. And while it's not regulatory, it is often required that nutrient management be done by farms who are participating in funding and grant programs from USDA. So many farms participate in those programs, so nutrient management gets in through the back door that way. And so nutrient management obviously is nothing new. The planning's been going on for a long time, and this is a real simplification and certainly not my area of expertise in comparison to the prior speaker, so I defer to that kind of expertise. But basically there was an early focus on nitrogen and the leaching groundwater pathway, and now phosphorus is obviously a major concern, especially in this room. So we're going to look at, there are recent state examples of in many states that are looking more at nutrient management and regulation of nutrients far more. The big growth in the last decade has been in state turf and lawn fertilizer regulations, trying to get at that non-point source pollution of phosphorus. And there's about 16 states that have focused on that with specific standards and regulations. Some of those exempt biosolids and other residuals, including compost sometimes, and some exempt agriculture as a whole sector, and they're focused just on the turf, lawn, grass area. Now in New England, there's an interstate group that decided, as these regulations were being considered by different states, they came up with this idea, well, let's try to get together and create a model regulation that could be used by the whole region. And of course that ever happened, and different states participated, and then the different states went off in different directions. But there were some common features, and these were picked up from places like Wisconsin and others who had already adopted these regulations early on. Interesting to, just be aware that jurisdiction of fertilizer tends to be at the state level. There is no real federal, as far as I'm aware, regulation of fertilizers. APFCO is an interstate group that tends to try to bring some harmonization to state regulations or provide model regulation on fertilizers. So they're working on all this stuff in the background. And basically what's happened with the state regulations of phosphorus is that they've come to agreement basically on these major things, all of which make great sense. Okay, you don't need to fertilize your sidewalk and have it run into the storm drains. Winter months, a sidewalk covered with ice versus a dirt road covered with ice or a lawn covered with ice acts pretty much the same way. It's an impervious surface. So these are all things which everybody agrees on and are making a lot of sense. And the basic premise of these is fertilize where there's a need, okay? But figuring that out is exactly the whole nub of the issue, is what that exactly means. Some of them restrict sales of P-containing fertilizers. Massachusetts, which I'll talk about, is a very restrictive regulation, very comprehensive. They sort of did the all-in approach and addressing both agriculture and lawn and turf. But this is a sign. I think it's a really confusing sign, actually. I mean, you look at that, if you see that quickly in a store, it's like, I'm not sure, this stuff here, it makes sense. But this is the required sign that people have to use in stores in Massachusetts. And the idea is that basically they're now segregating the zero phosphorus fertilizers from the fertilizers that have phosphorus in the store. They have to be segregated, and this sign has to be prominent. So it's an interesting approach. Again, kind of a good idea. I think it's very supportable, but it needs a little less busyness in that sign, I think. So Wisconsin was one of the early ones, and it's just an example here. It prohibits the application of fertilizer that contains P to lawns, etc., as long as, unless there's a need shown. It exempts agricultural production. It does not apply to use of manure that is ground, dried, pelletized, or to finished sewage sludge products, biosolids. So again, another exemption. So it's pretty simple and pretty specific to fertilizer, lawns, and turf, and phosphorus. And you can use it to establish, because again, early cool stage growth sometimes needs phosphorus when even if there's abundance in the soil. So, and then the various states have nice little ads I always enjoy those. So that's a kind of a little peaceful, I get to pause a second. And here we go, further. So regulatory barriers to recycling P. Yes, there are. But they're not, the barriers really aren't in Part 503. The biosolids regulations, again, are pretty basic at the federal level. The Food Safety Management Act, again, there's no real additional regulation of biosolids or other residuals. There is a little more regulation of manure, but mostly focused on pathogen concerns. The Code 590 is becoming, as I said, more heavily implemented and more required for funding programs. And it does cause some restrictions in biosolids and application when you have excess phosphorus, because it's a nutrient management program, and if you've got a soil excess in phosphorus, then you're going to be restricted on whatever you put on it, including biosolids, residuals, compost, etc. It's in the state regulations that there's significant impeding happening with recovery and recycling of biosolids. That's what I'll focus on for the next couple minutes. Again, the state regulations are inconsistent, and sometimes there are policy conflicts involved in them, not surprisingly. Many states are focusing on turf grass, and that's where a lot of Class A biosolids products are used. In the biosolids world, there's been a drive over the one consistent trend in the last 10 years or more has been a movement from having sort of bulk manure-like Class B biosolids, which contain some pathogens, being used like manure on farms, to having more diversity in end product uses of Class A compost products or pelletized like malorganite type products, things like that can be used in a whole lot more different markets, including agriculture, but also turf and home gardening and landscaping, etc. And so with these state regulations focusing on turf grass, they are now then playing in the same field as these Class A products, which have been burgeoning and increasing in volumes. So some conflicts are coming into account there. And in all of these state regulations, if the state regulators who wrote them are thinking about biosolids or compost or such, or organic residuals, if they think about them and they're smart, then they just exempt them because they don't want to deal with the complexity of those things. And that's what's happened in a bunch of states. But in some states, like Massachusetts, they don't exempt them, but they don't address the complexity and don't provide any understanding of how to abide by the regulation and use those materials. So here are the real core issues. We'll walk through each of these. So using soil tests. So soil tests have been used for decades, and the major soil tests used are used to measure agronomic parameters in order to predict nutrient needs for crops, right? So they use various extractants. It depends on what region you're in, what kind of soil test, Morgan, modified Morgan, Bray, Malick 3, et cetera, which one you use in that state. And those are all calibrated by those states to be able to provide a good, fairly powerful recommendation for fertilizer application. But what happens is that those are really measuring some kind of critical soil test level that applies to the agronomic need, right? But very often, absent any other data, the environmental regulators who are trying to understand soil phosphorus levels in soil are using those same agronomic soil tests to try to, and applying them to environmental relevance. And that's not necessarily appropriate. So in most states, there'll be an optimum level of phosphorus, and above optimum is defined. There's a threshold there, and so the state regulations will say if you're above that threshold, you can't apply additional phosphorus, or you have to apply it in certain ways or in a reduced fashion, et cetera, et cetera. And those numbers are different from state to state. But somewhere, and it's not at the same point, somewhere there's an environmentally relevant critical level that's different, and that has not been well defined in most cases. So that's an issue. The second is source P solubility. So there was research at Penn State and University of Florida and elsewhere that has demonstrated, and this may be something you're familiar with, that the solubility and immediate availability of fertilizers and amendments varies. And the triple superphosphate, obviously made to be highly soluble and available for plant uptake. But when you look at manure or poultry and you're using a water extractable, phosphorus water extractable test, which more appropriately imitates what's actually happening in the soil in terms of solubility, you end up with much lower availability of even in manures, but also especially in conventional biosolids, and that's because of the iron, aluminum, and other binding factors in those residuals. If you have a bio P, which is a biological phosphorus removal system in a wastewater treatment plant making biosolids, then you don't have that iron and aluminum binding, so it's much closer to a TSP availability. So this just shows research that kind of demonstrates the impacts of this, that if you have, this is from Chip Elliott at Penn State, the yellow is the dairy manure, the four middle ones are biosolids products, and then a control is the black on the right. And in terms of runoff P, actually measured over time in the soil, on the soil surface coming off of these experimental plots, dairy manure, you see very high levels of soluble available P running off, but when you look at the biosolids products, they're much lower in that runoff P because of it's less soluble. It's bound more tightly to the organic and mineral matrix of the biosolids. The third item, we touched on this a little earlier in one of the prior talks, is this beautiful work that people have done to understand the net flux of phosphorus in and out of different counties across the U.S. So where it is blue, it means your net exportation of phosphorus exceeds your importation. So there's a net export of phosphorus, obviously where all the feed and food are being grown and then exported out of the region to the denser populated areas of the coasts, for example. And the darker colored areas, darker redder areas, warmer areas are the ones where you have a net importation of phosphorus going on. And this is the big picture. This is the NUGIS summary of the same information, essentially. And the fourth item where state regulations have difficulty dealing with the complexity of this and these nuances and details is the imbalanced nutrients in biosolids and residuals. So manure, as we know, and biosolids in particular as well, have a high level of phosphorus in comparison to nitrogen when you look at crop needs. So when you apply biosolids, manures, and some composts, you end up applying more, and you apply it at a nitrogen rate agronomically to feed the nitrogen needs of the crop, then you end up applying excess phosphorus. So over time, that's of course how in a lot of situations soils have built up in excess phosphorus is because of repeated manure applications. So on a farm, the fields right near the barn have very high phosphorus typically because people have had their manures going right out to the easy place right nearby the barn over the years, and that's led to excess phosphorus. So what it ends up happening is that you end up sort of having these regulations that are written with this kind of vague language like available phosphate. So looking back at that, which soil test do we use? The agronomic test to define available, or can we use the water extractable test to define phosphorus availability? And then in Maryland, again, environmentally relevant versus phytoavailable P in the phosphorus management tool. What does that mean? In the Massachusetts regulation, it's pretty poorly written. They're not really biosolids weren't really considered, and they cite UMass guidance all the time. The agriculture department is not really into writing regulations. They don't have a lot of experience with it, so they really defer to UMass guidance, but they did so without ever really talking to UMass about whether they wanted to accept that responsibility, and they didn't. So right now it's all in limbo. The regulation's been in place about 3 years, but there's no real guidance for a lot of things. Meanwhile, the state of Massachusetts, another arm of the government, is trying to aggressively get organics out of landfill. They have a very aggressive regulation to keep organic materials out of landfill, so they're creating more products that have phosphorus that are going to go onto the soil. So here's the big question that they're facing and other states are facing, which is with respect to the recycling of organic residuals, the question is to what extent soils can be loaded with phosphorus beyond agronomic needs without environmental impacts. So our next steps is we're trying to help Massachusetts in particular, but other states as well, how to figure out how to deal with organic residuals in this regulated new structure. And we're trying to push for the idea that water extractable phosphorus should be allowable as a way to measure phosphorus, et cetera, so that we can keep recycling these materials, because there's benefits to recycling these materials. Counter argument is, you're still ending up putting more phosphorus on the soil, and that's going to be a time bomb perhaps in the future. So, got to do it carefully. Phosphorus recovered technologies is important. So the improvements to the state regulations are these. Regarding soil test interpretations, that first issue, we're trying to push for the idea of don't just rely on agronomic tests, use environmentally relevant tests like the water extractable phosphorus. Include source solubility in the calculations, and there are many state site phosphorus site indices that are now using source coefficients that make allowance for the fact that the availability of phosphorus from biosolids is lower. Try to correct these imbalanced phosphorus flows by cycling nutrients locally before you bring in outside nutrients. Prioritize the cycling of local P. Imbalance in the nutrients, we've got to extract more phosphorus out of those materials so they become a little less imbalanced. And I mentioned the site index. Here's the top priorities, though, then. First of all, we need to balance these conflicting realities. Any excess P is a potential long-term risk, right? But at the same time, there's a real benefit to recycling these economic, social, other benefits of recycling these materials like biosolids, which they exist. We need to do something with them, and putting them in a landfill I don't think is a sustainable option. So we've got to balance those things, and they're conflicting. Maybe they're interim things that we do for now, and then we get into these higher priority things, which are the longer term solutions, and everybody here knows about these ideas. We can reduce mined P use, prioritize incentivize recycling of local P, and then advance the removal of phosphorus from manures, biosolids, and digestate, and move that concentrated P to areas that really need them. So thank you for your time, and I don't know if there's time for questions, but thank you.
Let's take time for one question or maybe two. Anyone got something for Ned?
I got away with it.
Don't be shy. All right, Krista.
Have you all been working yet with AFCO on trying to integrate some of these newer definitions into what they're considering like a model bill?
Yeah, so AFCO does model regulations and bills for states, and there's a gentleman named Ron Alexander who the U.S. Composting Council has helped keep going, involved in the AFCO meetings. So he was there. I talked to him a few days ago. He was there AFCO meeting last week, and they have made some progress. They got an updated compost definition approved by AFCO and integrated as of last week, and he's raising these points now to try to again get AFCO, this is the state fertilizer officials, up to speed on this kind of stuff. So yes, not enough effort, but fortunately we've got him at least that much.